Hello. In this video, I'd like to discuss the solver or the optimization problem which I gave you. But first, let me discuss the conceptual part of it. I will start with talking about a problem. So I have two products, product A and product B. These are like a chocolate candy. And so the first product, one piece will generate 6 SR per piece. And other product, the product B, will generate 5 SR per piece. The question is, how much do I have to, how many pieces of product A and how many pieces of product B should I generate, should I produce to maximize my profit? So we can say the sky is the limit. You can produce as many as 6 as product A, and you can produce as much as product B without a problem. But there is a problem because I have a limited supply of milk and chocolate. My supply for chocolate, for instance, is what? My supply for, let me just give here a picture shape. Okay. My supply for milk supply is 5 kg. This is 5 kg only. And my chocolate supply, just copy this, there. Chocolate supply, supply is what? Is 12 kg. Okay, I'd like to note that for milk, it's put it here. For milk, it is 5 kg, and for chocolate, it's 12 kg. And therefore, I cannot really produce a lot, gazillion of product A and product B, because I'm limited with my supply. If the amount of milk and amount of chocolate is like there's no limit, then there's no limit in the production of product A and product B. And so I have to work along this line. And if I have to work along this line, I have to know which part of my product is consuming milk and consuming chocolate. In this particular case, product A, for one piece of product A, I need 1 kilogram of milk and 3 kilograms of chocolate. And for product B, I need 1 kilogram of milk and 2 kilograms of chocolate. So the product A is the more choco, right? You can say, we can call this more choco, and this is the classic choco. You can call it that way, as to have a nice name for it. Now, given this particular understanding of the problem, how many, because I can produce just product A. I can just produce this product, more choco, and forgetting the classic choco, forgetting this. And in that case, I will be producing only 5 kilogram, 5 pieces only of of this particular product of more choco. But if I do that, 5 kilogram, all right, then I would need 15, which is not enough. I have 5 kilogram here of milk supply and 12 kilogram of choco supply. So having understood this particular problem, let us go a bit more. So let us put it this way. More choco is product A. Huh? Product A is milk choco. More choco for. So I have for the profit for product A. So translating this, translating my picture over here, product A, the profit is for more choco is 6 SR per piece, and for the classic choco, I have the profit for B is what? 5 SR per piece. So the total profit from A, the total profit is what? The profit of A, 6 times the quantity. Quantity being QA is the number of pieces of product A, which is in this case the more choco. Right? So let me arrange that, fix that. And similarly, the product B is quantity B times the profit B. We have the same formulation here. And so therefore the total product or the total profit is an addition only. You multiply this, you multiply that to piece of A, giving you total profit A, and then you add them together. So you have your total profit. So take note also that we are highlighting this here. Your milk supply is 5 kg and your choco supply is 12 kg. And milk requirement for product A. Milk requirement for product A is 1. Milk requirement for product B is 1 kilogram per piece. And there is here, it should be milk requirement for product A is per piece of B. There. And this is chocolate requirement for product A is 3 kilogram or 1 kilogram, 3 kilogram per piece of product A. And actually we can just remove this since we already have the variable there. Okay, so there's actually no need for this. I'll just write it down. What happened there? I just copy this. All right. And so therefore the total milk supply needed or the total milk required is, you just multiply the number of pieces times the milk requirement and the number of pieces of product B times the milk requirement in product B, so that you have the total milk requirement, and this should be less than or equal to the milk supply. This one should go there. And choco, Q sub A, the number of product A, you look at the lower part, the chocolate, plus this, and look at the lower part, and that will be the total milk requirement or chocolate requirement, and that should not exceed 12 kilogram. Now, assuming this should be solvable by this problem should be solvable by using solver. But if I do not know solver, what should I do? Then I will do a process of guessing. So let me just write down up here. I'm going to give you this spreadsheet. All right. So you have here. Oh, I already solved this problem. So this is the quantity. The quantity will be there. Let me just write down 2 and 3. Let me just write here. The answer was 2 and 3. I'm going to erase this now. 0, 0. Okay. Let me just focus your attention on the lower part here. I want to focus your attention here. From here to there. I'll put a border. All right, there. There. As you can see, this is now the number of pieces. Number of pieces for the more choco, and number of pieces for the classic choco. And therefore, I'm going to make a guess, whatever it is. So 1 and 1, and I'll see the result. I'll check for the result. What will be the result? So this is the first order. I'll do like that, and I'll do like this, because these are guess. And then this will be the effect. So now these are now the effect. I'm now testing for the effect here. Okay. These are now the effect. The profit effect. Profit from A and the profit from B. And these are what you call effect, profit effect. Profit effect of decision. So basically, what happens is that these are possible decisions. Possible decisions. So if you choose 1 and 1, the effect is you have a profit of 6 and a profit of 5. So this is the result. Total profit would be 11. Still with me? And if you choose 1 and 2, the profit effect is 6 and 10. Here is the unit price. That's the unit price. 6 and 5. So you see the formula, B12 or B15 times $D $12. And then here it's C15 times $E $12, giving you a total of D15 plus E15. Okay, so it goes like that, and as we continue, so this is the profit. So we now make this smaller because this is another issue here. On the left border. All right. So here we now talk about the recipe. So this is the milk recipe, milk required, and milk required, no? For either product A or product B. Product A, product B. So for product A, it's just 1-on-1, whereas for choco required should be required. It is 3-2. Here milk required. This choco required. So you have 2, and then like that 1-1. So you see, if you, for example, just for example, you decide to produce 1 and 3, the effect is that you will be needing 1 kilogram, 1 and 3, 1 and 3, 1 kilogram of milk and 3 kilograms of milk, giving you a required kilogram, 4 kilograms. Get it? We should change this by all right. And here for chocolate, if you say 1 and 3, then you will have 1, and because that's 3 times 1, you get 3, and then this one becomes 6 because there's 3 times 2 equals 6. Now you need a total of what? 9 chocolate needed, no? 9. But you know very well that in the warehouse you have 5 kilogram, 5 kg available. And here in the choco, you have a 12 kg available. Yeah? So now all we have to do is to check from here 2, 3, 4, 5. That's feasible. Here no more. We cannot go for this solution. We cannot go for those solutions because these are not feasible. You only have 5 kilograms. But here you have 12 kilograms. So therefore 12 from here to here, these are not feasible. So you go like that. Not feasible. So you only have, in effect, what is feasible would be this. Those solution. That's feasibility. All right. That's feasibility, and I'm going to change them to. All right. So along those area only are feasible. And what is the maximum profit? 26. From my point of view, it is 26 because in 26 you can now do 6 and 20. If it is 20, 6, you can do 1 and 4. So you have 26, and you have 1 and 4. You have 5, and here it's 11 within the required. No? So 26 is our answer here. So let me now put them into a square bracket there. Now, is this the optimal solution? Is this an optimal solution? So we now try our linear programming. This is a layout. You see, in order for us to use the linear programming approach, this is the layout. You see earlier, This was solved previously, but I'm going to to show it to you again. L Let me just discuss this this part. The answer was 2 and 3. What was the solution? 27. This is the profit, 27, as against 26. So by trial and error, we are what we refer to as maximizing, or we are satisficing. By trial and error, by trial and error, we are saying to be, we are satisficing. We satisfy. We are satisfying. But this approach here, this approach here, this approach is what we refer to as optimization. So by optimization, by doing this by using linear programming or solver, we are optimizing. That's why we say we are doing optimization. Okay. Now, my we stop here. My next video is to explain how to do this part, because this is the start of that optimization and linear programming. Okay, so let me just copy this, and we end here.